Okay, scientists, in this video, I want to show you how to use the general equation for objects moving at a constant velocity and the velocity you get from a rate of change calculation or the A value on Desmos to write an equation that models the motion of a specific object. Okay? And then how you can use that equation to do a calculation to predict the distance an object will travel in a certain amount of time. So what you see on this Jamboard is the general equation that shows the relationship between distance, velocity, and time for any object moving at a constant velocity. And what this equation says is the distance an object moves is equal to the velocity of the object multiplied by the time it takes to move. And we determined that this equation works for constant velocity motion by looking at graphs of constant velocity motion and what the rate of change told us about that object. Okay? So for any object in the universe, if its speed's not changing, it can be modeled using d equals vt. Now, you have also learned to calculate a rate of change or to graph a set of data on Desmos and get an A value. Both of those things, the rate of change calculation and the A value in Desmos, give you a velocity, how fast the object is moving in a specific direction, if direction is indicated. Okay? Now let's say you have a car and it's driving down the street and you collect some data about it. All right? You graph that data and it reveals a rate of change or a value of 12. That means that object is going at a velocity of 12 meters per second. Okay? We now know something specific about its motion, and we can use that fact right there, the fact that the velocity is 12 meters per second, to write an equation that models specifically this car and its motion. Okay? And that's as simple as substituting the number in for the letter V in this equation. Okay? We want to change V into the specific speed or velocity of the object. And to do that, we take the V out, we put the number in. It's as simple as that. And we rewrite the equation. So the distance that this car is going to move is equal to its velocity of 12. And you don't have to put in the unit meters per second, t. And just remember, when you have a number or a letter or two letters next to each other in an equation, that implies multiplication. Imagine there's an invisible time sign right there. Okay? So we now can say the distance the car travels is equal to 12 multiplied by the time it is moving. All right? Now to use that equation, this is what we do. Let's say, for example, that the car is driving for 30 seconds. Okay? To find out how far it goes, we just have a simple multiplication problem. And I'll show you how I will set up that problem using this equation. Okay? Distance is equal to the velocity, and now I'm going to put the unit in, 12 meters per second. And I'm going to put it in parentheses because parentheses mean multiply as well, multiplied by the time, 30 seconds. Okay, multiplying 12 by 30 gets you 360. And it's 360 meters. All right. Then we've used our model, d equals 12t, to predict that in 12 seconds, a car will travel 360 meters. All right, it's as simple as that. Start with d equals vt, substitute in the velocity, which you get from the rate of change calculation or the A value. That gives you your specific model for the object you're interested in, and then you can use that model, that equation, just by doing a simple multiplication problem to find the distance the car goes. Hope that helps.